Hello everyone. Today we will discuss about the next terms, that is a symmetric cryptography. Okay. In the last class, we discussed about the cryptography, like what is cryptography, why we need cryptography. So we will just recall in a few minutes, then we will come to the symmetric cryptography. Okay. So let's see why we need actually cryptography. As we discussed for the confidentiality, okay, confidentiality and the integrity, authentication, and non-repudiations. Okay, for those purpose mainly we need the cryptography. Okay, what cryptography works for making a hidden transmission. Okay, so that nobody in the middle can read that. Okay, now there is a different method to do the cryptographic things. There is a hash function methods, right? Symmetric, asymmetric. Now we will works for the symmetric cryptography. Okay, so we understood about the cryptography concept history. Now let's talk about the symmetric cryptography. So what we will study in this symmetric cryptography, we will cover what is symmetric cryptography. Okay, we will cover about what is symmetric cryptography, okay, how it works, okay, how it works, what are the advantage, okay, what are the advantage, and what are the few methods of it. Okay, few methods of it, and rather later case studies. Later we will study also case studies. Okay, these kind of things we will study, and then we will summarize it. Okay, we will cover these kind of things in the symmetric cryptography. Okay, as you guys know, this is a series of introduction and foundation of cyber security understanding things. Okay, let's come to the our objective. Okay, our objective is understand the symmetric key cryptography, learn how encryption and decryption works, identify common symmetric algorithm, apply concept using real world examples. Okay, let's see the learning outcomes. After this session, students will able to understand as symmetric encryption clearly, identifies where symmetric encryption is used, choose suitable algorithm for encryptions, understand key management challenge. These kind of things can be understood. So let's see the outline, working principle, popular symmetric, real world case study, scenario based problem, and limitation summary and introduction about the symmetric cryptography. So let's come to our today's topic. Let's we start the today topic now. So let's see, use the what is symmetric cryptography. Okay, now if we want to see the what is symmetric cryptography, that means using the same key. Okay, sometimes we say the secret cryptography also, because we use the same key. Here we use the same key, so that means that is kind of a mirror, that is kind of a mirror, that is kind of a mirror, right? That is kind of a mirror or inverse, right? What is that? Why we say the symmetric cryptography? How it works? If we say mathematically, suppose here we are doing an encryption by multiplications, right? So decryption is division. Okay, suppose here we are doing addition. So decryption is minus. So this is encryption. Okay, this is decryption. Suppose we are doing sin x. This will become the sin inverse x. Okay, like that. So this is nothing but inverse. What we do for the encryption, that decryption is the inverse of that. Okay, that's why we do the symmetric cryptography. That's kind of a mirroring we are doing. So whatever we are doing with the help of single key, with the help of single key, with the help of what? Single key, we do the kind of mirroring work, right? Suppose we are doing in the encryption, we are doing multiplication, then decryption we do the division. Suppose we are multiplying by 5, because we are multiplying by 5 to make an encryption in between so that nobody can read it. But when we want to make a original text, we can divide by 5, so it will become a original text again, right? So like that it works. Suppose, see there, suppose there is original text. Suppose there is original text. What is the original text? Suppose the original text is, suppose there's the original text is 1, 5, 10, 15, right? What we are doing in the encryption stage, we are dividing by 5 to each. So this will become what? 0.2, right? So divide by 5, 0.2, this will become 1, 2, and 3. Now this message, original message this, but it become at transmission stage. At the transmission stage, this original message become a this one. Now nobody can read it in between. If they can read also, they cannot understand it. So it's a hidden message, right? It's an encrypted message. But what will happen when it become to a decrypted? We know because of the key is what? Division by 5. So we know it's divided by 5. So for decryption, we will multiply by 5. This is how encryption and decryption work. So it is like a mirroring things or the inversing things. So that's why it's called a symmetric cryptography. Where it is usable? Because we are seeing here the same key is using again at the first stage and the second stage. So what happened? While we are using same key, that means while we are using same key, that means it is fast so that it is usable for the large data encryption. So just one example we give. Okay, suppose when you contact the new number in WhatsApp, when you contact, first send the message hi to the new WhatsApp number. It is not a symmetric cryptography, but because this is not in your context, so first it is established the different cryptography that is kind of asymmetric. We'll discuss about that later because it's unknown to you. Because it's unknown to you, you don't know, you do not chat usually or daily, so that's called a asymmetric one. But what happen later when you exchange fast chatting, fast messaging does, right? You need a symmetric cryptography, right? Then later when a person becomes to known to you, when you add fast conversation, fast transfer of data, it will become to symmetric cryptography, right? So you can say when first message start, it become asymmetric. We'll discuss asymmetric later, but now we are coming to the symmetric only. So when you want a fast conversation with a large data and securely shared between the users, then we need the symmetric cryptography. Okay. Now I hope it understood to the person, right? It's easy to understand, right? It's a one key. Okay, that's why sometimes we see sometimes it's a different name is a secret cryptography. Okay, sometimes its name is a secret cryptography. Okay, sometimes its name is a secret cryptography. Okay, secret cryptography. Okay, sometimes name is a secret cryptography. Encryption, decryption between the cipher text, that means hidden text. Cipher means hidden text. Okay, I give you the example how inverse comes and later it become a original text. Okay, suppose this is a suppose this is a person, right? Suppose this is a person here. Suppose this is a person here. He has a mobile phone, right? He or she has a mobile phone. Okay, he has or she has a mobile phone. Mobile phone has some app, suppose a WhatsApp. You can see in the WhatsApp that message come and to end encrypted, right? What does it mean? That means there is encryption is going on. That means nobody can read your message in between, right? So maybe somewhere there is symmetric cryptography is going on while your conversation of going, right? While your conversation is happening. So let's see. This is a person 1, P1, and this is a person 2, P2. Now, when this person send a message to this, if it the hello message or some suppose some message important message goes to like long important message goes to this person without the encryption, if there is a transmission medium, right? There's a network medium. There are attackers, right? They can read the message. So there will be problem for the confidentiality. Then there's the problem of integrity. Then there's the problem of authentication. Later, there can be the problem of reputations, right? Understood? So we want about that. What we want that in between nobody can read. Although they can check the data, but they cannot understand it, right? So nobody can crack the in between details. That's why we use what? Encryption. We use the encryption. If we use the same key for the fast and efficient process, we need a symmetric cryptography. Okay, we need a symmetric cryptography. Now what happen? It's a hidden language comes and that hidden part going to change by the decryption in the original message. Okay, that's how it works. Person 1, person 2. Okay, that is a D, that is a E. In between cipher goes on like that it works. Okay, I hope now it's very clear about the symmetric cryptography and why it needed and how it saves the information, right? So because there is a network, there is a many theft is sitting, many attackers are sitting, okay? Many hackers are sitting between the network, right? Over the day, over the night, right? So they can read your chat, they can read your information. There's nothing to secure between. So you will not feel secure to use the some chatting apps, right? So that's why that's needed. I have understood. Okay. Now let's go the next thing. Simple example. We understand how it works. Okay, simple example. Let's see. I told you previously the key is what? We took a secret key is by division by 5. Now let's say the secret key is a 3. 3 means addition. Okay, addition. That means H become a K. I, J, H, K. Okay, H become a K. A, B, C, D, F, G, H, I, J, K. Okay. Okay, H become a K. E become a H. L become a O. L become a O. O become a R. O, P, Q, R. Okay, so third place. P, Q, and R. Okay. So this become hello become a who. Normal, simple encryption. You can use this things by crypto tool also. There is a one tool you can perform this test in the crypto tool. That tool available online. You can download freely and you can perform this test by using a crypto tool, right? So now you understand how simply this algorithm works, right? Suppose this person one, suppose this person one P1, it send a message here, hello. Now the key is addition of 3. So H will become K, okay, this will become H, this will become O, and O will become R. Now in between the message is a cool. Nobody knows what is cool, but actually it will decrypt again. How will it decrypt? Because addition is plus 3. So it will become minus 3. So now K will become H, H will become E, O will become L, R will become O. So 4 will become hello. So what happened? It's a opposite, right? That's why it's called a it's an inversion. That's why it's called a symmetric cryptography. It's plus, then minus, multiply, then division, okay? And any sign, then inverse, cos, then inverse, like that, right? Okay, I hope this point is very clear. Okay, now we understood about the cryptography by using some example. Okay, let's see the next symmetric encryption working flow. How it works? Simply we can see here. How it works? Sender encryption using secret key, ciphertext, decryption using same key, then goes to the receiver and then receiver decrypt it, right? Receiver can receive it because decrypt message come the original. So if we see here, original message goes from original message, here also original, in between hidden message. Okay, that means changed message. Okay, that's the how workflow is there. Okay, of the symmetric cryptography. I hope you understand it clearly. Now let's see what are the popular algorithm for the symmetric cryptography. Okay, so there are the DES, CDES, and AES algorithm are the popular algorithm. So if we talk about the DES, it's a very old algorithm. Okay, that is started in 1977. Okay, and that is bit oriented algorithm, and in that the key length is 56 bit, as it mentioned, right? Key length is 56 bit. Key length is 56 bit. That means if somebody want the brute force attack, they need the 2 to the power 56 times permutation and combination. Okay, so that they can break the key. So that is quite difficult but also easy. 2 to the power 56 permutation combination of 0 1 1 0 kind of things they can do. Okay, now 3DES means 3 times perform the DES things, DES algorithm, right? What does it mean? What does it mean? 3 times performing the DES means data. What does it mean? 3 times performing the DES. What does it mean? If I say I perform the 3 times DES, what does it mean? That mean is we are performing the 3 times the data encryption standard. Okay, what does mean that triple DES we say it, right? We say what? 3 times we are performing the DS. That means we are using the 56-bit keys by 3 times. Okay, that means 3 distinct key we are using. Okay, how we are using 3 distinct key? That means 3DS applies the DS algorithm 3 times, typically using the distinct 56-bit keys. Okay, now if we see here, what happened if we see here, if I delete it, okay, so what happened here, if I want to tell you the same thing, what happened here, so if I say typically using 3 distinct 56-bit key, that means 3 times if we use the 56-bit, so what will happen here? 56 plus 56 plus 56. That is kind of 5, 6, 6, 6, 8, right? 5, 15 and 116. Okay. Okay. 168. But here is a 192 bit. So it is kind of 64 plus 64 plus 64. Okay. It saves a 3-time DES algorithm performed at the K1, K2, K3. It's kind of encryption, decryption, and redecryption kind of things is going on 3 times. Okay. So what happened? There is a 192 bit space for the keys, right? What happened? There is a space for the 192 if we stored in the 60-bit 64-bit format using a 8-bit for partly. Okay, but happen what? Effectively there are a 196 168-bit. Okay, effectively there are a 168-bit 56 56 56 cross 3 because DES has what? 56. So effectively 168, but it is stored as a 64 cross 3. So it's a 192. Okay, but effectively 168 bit. Okay, I hope it's the concept. Understand what the meaning of 3DES and why we used, because of the more bit power, right? More bit power, that means more brute force will be needed here. More brute force will be needed, 1 to the power 192. I will explain you the application also slowly, where it is used and what are the other applications. Okay, so I hope you understand about the 3DES. That means data encrypted, 3 data encrypted standards. Okay, that means what happens here, it is stored in a 64-bit format using a 8-bit of parity check, right? But what happened, total storage requirement will be the 192-bit, but there is a 168 effectively bit. Okay, so what is the security level here? The 3-key method provides roughly 112 bits for of effective security for stronger than the 56-bit offered by a single DES. So what it makes, make a more secure offer here. Okay, now let's understand about the AES, advanced encryption standard. Okay, what happened? It's advanced, right? So we can see here 128, 192, and 256 bit, right? So if we talk about the 256 bit, that means many brute force needed to crack this key. Okay, now what happened? It started at 2001. Okay, and that started at 1977. So very long before it started. Now it improved to the AES. Nowadays, if we see what is going on, mostly AES technology are using, but where are the compatibility matters, some other issues matters, still the AES using with the some places. Okay, but nowadays 3DES is changed for after the DES, but nowadays AES is using in many sectors. Okay, so this is the, if we talk about the things, these are the actual things by the DES to the 3DES to the AES. So if we say the AES is a byte oriented, because in the many bits 128 to 192 if we see, right, 128 to 192 to 256, and previously DES is a bit oriented. Also the structure is based on a substitution permutation network, and that's a structure based on a Feastal network. That's a different concept we can study. So that is related to the DES. And triple DES, a more secure variant of a DES, applies DES encryption 3 times sequentially that we already discussed. Okay, so what happened here? So data encryption algorithm, that algorithm is a old one and easy to attack. That's a vulnerable kind of things, right? But AES is a more secure algorithm because it uses a advanced encryption standard with the high secure level byte, right? So what happened here? It uses in the many application. Okay, wireless security, VPN security, disk encryption, data storage, mainly using the AES. Okay, so what happened here? Although DES was widely used for many years, but it has been it has since been deemed less secure due to its shorter key length, making it vulnerable. Okay, now the many things comes to the from DES, 3DES to AES only. Okay, I hope you understand the concept of properly AES and DES. Okay, so we mainly understand the block size of DES is 64 bit. If we see the block size, if we see the block size, that means the I told there's a bitwise and bytewise, right? This block size is 64. I told you, right? That's why this is 192, but effective is 168. That is 56. And here block size is 128. Okay. Here block size. This block size also increased here for the more storage and more secure. Okay. Also, if we talk about the key length, we understood 56 bit and 128 bit. Block size there is 64 bit, but key block size here is 128 bit. Structure we have already discussed about the Feaster and substitution permission network, and DES developed in 70s, and that AES is developed by, also if we talk about the AES more secure. If I talked about the AES, that was developed mainly very early by IBM, very early IBM, but that is developed by the NIST. NIST means what? National Institute of Standard Technology. Okay, that is a US based security, cyber security standard. Okay, so that is a block storage 128. That is a block storage 64. But this is a key length is 56. There is a key length also 128. Right. That's how it designed and developed. So we can see from early days to the coming days, and it's also going to advance. AES is developed in 2001, but slowly it's going to advance to 256. Nowadays, I think it's going to the 1512 bit also. Slowly, they are achieving to 512 also in the upcoming years or the current years in the current cyber security frame. Okay, for making the large data transfer securely in the area of digital security. Okay, so like that thing is going on. So we understand about the DES algorithm, data encryption standard, and three times DES algorithm, and because of the security standard to make sure the key length should increase and the block space should increase. Now, AES is the mainly used wireless security, VPN security, network security. So currently we can say AES only using in the most secure places. But if suppose there is some compatibility issue, some other old issue, then we can use the DES also. So that is the most secure algorithm for the symmetric cryptography is AES. Okay, AES. I hope we understand this concept. Okay. So this is all about the AES and DES. I hope we understood about it. And if we talk more about it, we can say that AES later on improved by RSA. We will discuss in the hash function. Okay, later we will discuss. Okay. So also there's a important things that we understood about the key size, right? So brute force attack, key size, all and everything we understood, right? So we understood about the brute force attack, how many attacks they need for this? 2 to the power 256. For this, 2 to the power 56 only. That is very easy to crack. This is also improved but slow, right? This is the fastest and the industrial growth. Now, if we go to the next technique, that the RSA, we will talk about it later in the when we study about the hash function or the symmetric cryptography. Later on, we will discuss about it. But if we discuss only about the symmetric cryptography, then we have to think about the AES only. Okay, AES is the best symmetric cryptography technique. Okay, let's come to the next topic. Next slides. That is a case study. Okay, now we understood what is symmetric cryptography, what are the algorithm used, and when it developed, how it started, how it works, right? Let's see the first case study. Secure file storage. Okay, so organization encrypt file using the AES, same key required to open files, prevent unauthorized access used in a cloud storage and database. So this is a first case study where is a symmetric cryptography is used. Okay, that is used in the secure file storing system. Okay, we understood about that. Okay, how algorithm is going on, how to secure the file with the help of AES. Okay, first case we understood. Let's talk about the second case. First case is a secure file storage. If we do not use AES, then maybe here is a unauthorized access can be happen and no security, the security word will become a unsecure. Okay, let's see the next one. Online banking transaction, that is most important way, right? Suppose we are doing some transaction. Okay, that is, suppose we are doing from phone pay, right? We need a proper transaction security so that we done. So see, if you use the phone pay, if some new user comes, they give a warning to you, but when you add those user in contact, that happens due to that secret transaction or the secret key transaction, so that your transaction will be secure, right? So what happens? Session data encrypted using symmetric keys, high speed required for real-time transaction, keys generated per session. Okay, protect customer financial data. Like that, it happens in the online banking transaction. If we go to the next stage, there's the disk encryption in laptops. Okay, if we see the laptop also, full disk encryption, there's a third case. So full disk encryption using the AES protect data if laptop is stolen. Okay, if we encrypted our laptop data by using the AES, if our laptop is stolen, our data is protected. Suppose there is some important files or some important data of some design data, some company data, some patented data. We need to protect some defense data. We need to protect it by using the AES. Key linked to user login, and this key, secret key, is linked to the user login. That means only authentication, through the authentication only can crack the encryption information, or the can encryption become a decryption only using the authentication used in BitLocker or FileVault. Okay, where it used in BitLocker and FireVault. Okay, I hope you understand about those. Okay, let's see the scenario based problem to understand the real world scenario. Okay, the next slide. So what happened? Scenario, suppose let's see the one scenario based issue. A company wants to encrypt daily backup of customers. Okay, what company wants? Daily backup of the customer data. What discuss about which symmetric algorithm is suitable? Why is AES preferred? So we understood AES. Why AES preferred? Because AES is more secure and there is a 256-bit key for the uh, key length. Okay, maximum length. So we need a more brute force attack. It's the same. What happened? The key is leaked. What happened? Our data will become a vulnerable, and there are unsecurity issues, and that can be theft, and that breach what? Confidentiality, integrity, authentication, and non-repudiation things. Okay, these are the problems. Understood that we discussed about the scenario based problem. Let's see the next scenario based problem. See the next scenario based problem. Okay, for the next scenario based problem, if we have this one, scenario based problem 2. A video streaming platform needs a fast encryption for live content. Okay, for the fast encryption, what we need? Symmetric. Okay, what a discussion point. Why symmetric encryption is better than asymmetric? Because we need a fast encryption. Okay, when the secure we need, so that's why we need the encryption, and encryption need a fast, so that we need a symmetric. Okay, which property make this suitable for real-time system? Which property? Because we making the AES and it's a fast. So we are doing the fast encryption. We need the encryption because we are doing the security we are needing, confidentiality we are needing authentication. So that why we need a cryptography, and we need a fast, so that we need a symmetric AES cryptography. Okay, I hope we understand about it. Let's see the next scenario based problem. Okay, let's see the next scenario based problem. Let's see the problem 3. Scenario: two branch office exchange confidential data daily. Now there is a one branch and two branch. They exchange the confidential data. Confidential data means some technology transfer is there, Okay, details transfer are there. Anything can be there. Suppose Honda has technology, Coca-Cola has technology. This transfer is going on. What the main risk is in key sharing? Key can be theft. Now the problem in the symmetric cryptography, key can be theft. Okay, now what are the things? How can secure key exchange be achieved? Okay, now what is the problem here? Now this has become a limitations of the symmetric cryptography, because if we see here, this person, two-person is there, we are sharing the key as well, because there is same key, right? So here the problem of key thefting. If some in between person got your key, then what happens? Any between person can make a passive or active attackers. Passive attacker means they're just reading your information. They are not doing anything, just enjoying from your information. But active attackers means they can take information and harm you, right? These are active attackers. So in between, anyone can come. In between what happen? In between what happen? There is sharing same key. See there. I just delete it. The sharing using same key, right? Same key. If this is theft, what happen is theft by active passive attackers. Okay, passive attacker. So they can either watch it, either enjoy by watching, either they can make a harm. Harm means active attackers make a harm, right? Make a harm by active attackers. Okay, so what will happen? There is a problem with the this kind of scenario. What we have to do then? We should do not share the key. There is a one thing. There the thing is that thefting key, and we should not share the key. Then we need a different kind of cryptography, that is called a asymmetric cryptography, that we will study in the upcoming lecture. Okay. Now I hope you understand about it. Okay. So what we understood about it, because there is a sharing of the key, because same key is using for the one operation and inversion of that operation. Okay, so key is sharing. So what is the problem? Key can be theft. Now when key can, because key is also going with the data. If key can be theft, then what the problem? The active or passive attackers can harm the confidentiality, integrity, and authentication. Okay, these are the problem. Okay, now also one more good thing here. When we transfer the key, what algorithm is uses? Diffie-Hellman algorithm. Okay, Diffie-Hellman algorithm. Hellman algorithm. Okay, is used to transfer the key. Transfer the key. Transfer key. I hope you understand, right? Okay, let's talk about. Let's talk about. Let's talk about what we understood about the which key which method is used for the transfer key. Diffie Hellman. Okay, I hope you understand. Okay, now because we need a transfer of key, but asymmetric we don't need a transfer, so we do not need any algorithm. Okay, so we need a proper secure transfer process. That's also the one thing. We need a proper secure transfer process. Also one thing, secure transfer process, when we use the symmetric. When we use the symmetric, that is kind of Diffie-Hellman, and we need to more secure of the Diffie-Hellman by using the good algorithm. That is, we will discuss about it by, we will take the large prime number. Okay, we take the unknown number, so that we can make a secure and nobody can harm, but still key theft chances there. So that's why we come to the new algorithm, that's the asymmetric. Okay, so now we will discuss about the, based on that we'll discuss about the limitation of symmetric cryptography. Okay. Secure key distribution is difficult. Okay, because key can be theft, does not support non-reputation, because key is also requires strong key management, often combined with asymmetric cryptography. Now what we have to do, we want more secure, we need to combine with the asymmetric cryptography, that we will discuss later. Okay, now if we want to discuss about the next slide. So we understood about the symmetric cryptography and what the limitation of that. Okay, let's see about the summary. So what we studied about this topic and lecture, we understood symmetric cryptography use one shared key. It's fast and efficient. AES is the most widely used algorithm in symmetric cryptography. best suited for world data protection, key management is the biggest challenge. Okay, we understood about the challenge and about the symmetric cryptography. Okay, so what the main thing here? One key is used. This is key. Okay, this is kind of key we used. One key. Okay, one key we used. Okay, now what the problem? Key exchange is there. Key exchange is there. Okay, that is the issue because key can be tapped. Key can be tapped. And what the algorithm we use for the secure key transfer? Diffie-Hellman. But again, there's a problem. There's a definitely problem with the last data transfer. Key can be hacked. That's why we come to the asymmetric. Later on we will discuss about it in the next upcoming lecture. Also if we discuss secure transfer algorithm by the symmetric, because why? It's a fast and efficient. That's why we need to make a secure symmetric cryptographic algorithm so that we can make a fast transfer of the data. So what the current algorithm is? AES, and that is improving more so that we can make a fast and high data transaction or the transfer due to the secure manner. We need the security and fast and high transfer data, right? So that we need a symmetric cryptography, right? Although we can go to a symmetric, but that's a slow process, right? Because two keys are there, right? We will discuss about it. But if we need a fast and high data transfer within the limited time and the very fast transaction of the things, then we definitely need a symmetric cryptography and with the advanced secure key exchange algorithm. Okay, and sometimes we can use a combination of symmetric with the asymmetric algorithm. Okay, that is also the good point. Now we understand symmetric algorithm. What is symmetric things is there? Just an inversion of things. If we make a key with the division, then we need to make a inversion by the multiplication like that. Okay, so that is an inversion. That's why we call it symmetric, because that is a kind of inversion. That's why we call it symmetric. Okay, I hope we understand about that. Okay, now we understood the fast and efficient. That's why we need it. Okay, bulk data it can be transferred, but the key transfer process, that's why we need a secure key transfer algorithm. Okay, we discussed about the what key transfer process algorithm is needed is there, Diffie-Hellman. Okay, so we understood all about the symmetric cryptography. So thank you for listening the lecture. So once we again go to the first from last to first slide, so you can review again the all slides once again, and we'll talk in 1 or 2 minutes more, then we'll finish the lecture. Okay, so let's go to the again. This we studied this, then the limitation. We studied the case problem. We studied this case problem, and we will study the case problem related to the some second case problem. We studied about the live content, right? First case study problem we intend the stories. Okay, like what backup of the data, right? The description encryption we studied. Okay, what we studied the online banking system studies. We studied file storage things. Okay, so we understood about the different popular algorithm. This is the old one, 1977, 2001, and we understood how brute force, how much brute force needed for this, 2 to the power 56, 2 to the power 256. Okay, we understood how it works, working flow. We understood this is the how it goes. Okay, we understood about the what is the symmetric cryptography properly, outline, outcome, objective is finished. So I think this lecture is good for you. If you learn from it, please like it. Okay, so just I will summarize in 1 or 2 minutes what is there. So we understand about the symmetric, that means inversion. Okay, inversion, that means same key is using, or same key means some algorithm is using to make a inversion of the things. That means encryption and decryption use a key that's kind of inversion things, right? That's kind of mirroring, right? So suppose I am doing multiplication, so I will need division. Suppose I am doing plus, I will need a minus. That's kind of thing. Suppose I need a cos x, cos inverse x, something like that we use in the symmetric key. So that's why it is just a one key. It's a very fast and efficient process. What the theorem is used? DES, AES, but nowadays only AES. If we use a 3-time DES, it's a 3 DES. Okay, but current process algorithm for the wireless security, VPN security, network security, we use a AES algorithm, most efficient algorithm that has a block space is a 128 bit, and the key length up to 256 bit. Okay, that we used. Okay. Also, there's a one more things. Now we understood about the symmetric cryptography algorithm, fast and easy fast process, bulk data process, this kind of advantage there. But what are the disadvantage? The disadvantage is the key exchange is a problem. Key can be theft. If key can be theft, then in between the transmission medium or the network medium, active and passive attackers can harm the confidentiality, integrity, and authentication. Okay, that's why the smart and standard key transfer algorithm is needed. The one key transfer algorithm is a Diffie-Hellman algorithm. Okay, Diffie-Hellman algorithm. Okay, so that things we understood today. I hope you learned something from this video about the symmetric cryptography and the concept of cryptography and history of cryptography. Also, you learned about the AES, DES mainly, and what the disadvantage of sharing key. But although there is just one disadvantage, still we need a secure transaction method for the key so that we can make a bulk data transfer process fast in a secure and efficient manner. Okay, I gave an example of WhatsApp also, how the chat is goes on and how that works. Okay, and thank you to listen this lecture. And if you like it, please like make a hit a like button so that it goes to the many students and many learner, and they can give advice and they can learn together. We can learn together. Thank you. And I work in SA University. That's one of the prominent university in India. Thank you very much everyone to listen this. uh, okay, have a good day.